Hey there, welcome to TechWorldGBA, your go-to channel for all things tech. If you love staying updated with the latest in technology, gadgets, and tutorials, you're in the right place. In this video, we will go through detailed explanation on how to route requests to multiple VMs based on huge loads. To route requests to multiple virtual machines efficiently based on huge loads, while considering VM CPU and storage availability, you need to implement a robust load balancing system with considerations for dynamic resource management. Here's a detailed explanation of how this can be done. Key concepts and components. Before diving into the actual implementation, let's define the key components involved. A load balancer acts as the main entry point for incoming requests, distributing them across multiple VMs based on predefined strategies. Virtual machines, or VMs, are the compute instances that handle the actual processing of requests. Each VM has specific CPU and storage limits. A monitoring or telemetry system continuously monitors the performance, CPU usage, storage availability, and other resource metrics of VMs in real time. Autoscaling is a mechanism to dynamically add or remove VMs based on current load conditions. Types of load balancers. Different types of load balancers can be used depending on the system's complexity and architecture. A Layer 4 load balancer, also known as the transport layer, routes traffic based on IP address and port. A Layer 7 load balancer, or application layer, routes traffic based on more advanced criteria like HTTP headers, URLs, or content, and can implement rules based on application logic. For managing huge loads based on CPU and storage availability, Layer 7 load balancers, or customized solutions, are generally more effective because they can apply more granular control based on VM resource metrics. Load balancing strategies for CPU and storage availability. Several strategies can be applied to intelligently distribute traffic based on the CPU and storage availability of each VM. In a round-robin approach, the load balancer distributes traffic sequentially across virtual machines. However, to ensure efficient resource management, health checks can be performed to assess the CPU and storage availability of each virtual machine before routing the request. The load balancer keeps an up-to-date record of each virtual machine's CPU usage and storage availability. Before forwarding a request, the load balancer checks if the virtual machine has enough CPU capacity and storage. If the virtual machine is under heavy load, such as CPU usage over 80% or storage utilization over 90%, the load balancer skips the virtual machine and routes the request to the next available virtual machine. The least connections method directs traffic to the virtual machine that has the fewest active connections. This can be modified by adding resource awareness, where the load balancer considers the virtual machine's current CPU and storage state. Each virtual machine is continuously monitored for the number of active connections. Additionally, CPU usage and available storage are tracked. Requests are routed to the virtual machine with the fewest connections, but only if that virtual machine also has sufficient CPU and storage capacity. In this method, virtual machines are assigned weights based on their resource capacity, such as CPU and storage. Virtual machines with more available resources receive more requests. A monitoring system periodically assesses the CPU usage and storage of each virtual machine. Weights are dynamically adjusted based on current resource availability. For example, if a virtual machine has low CPU usage, say 20%, and ample storage, it gets a higher weight compared to a virtual machine with higher CPU usage, like 70%. The load balancer routes more requests to virtual machines with higher weights. Custom metrics-based load balancing is an approach where the load balancer makes decisions based on custom metrics. These metrics may include CPU utilization, memory usage, storage availability, and even application-specific metrics. To implement this, you need to collect real-time data on CPU, memory, and storage for each VM using monitoring tools like Prometheus, Datadog, or CloudWatch. Custom algorithms are then built into the load balancer to prioritize VMs with the most available CPU and storage. Traffic is routed based on a score that combines all these metrics, such as a weighted average of CPU, memory, and storage availability. VM monitoring and resource awareness are crucial for making load balancing decisions based on CPU and storage availability. This can be achieved through metrics collection and defining thresholds and alerts. First, use monitoring agents installed on each VM like Telegraph, Prometheus Node Exporter, or AWS CloudWatch Agent to collect metrics such as CPU usage, available memory, disk I/O, and storage. The monitoring system regularly updates the load balancer with the latest resource metrics for each VM. Next, define thresholds, for example, CPU greater than 80% or storage greater than 90%, that trigger alerts or actions in the load balancer. When a VM exceeds the threshold, the load balancer stops routing traffic to that VM until the load decreases. Auto-scaling ensures that your system can dynamically adapt to changing loads by adding or removing VMs based on resource utilization. Auto-scaling groups available in AWS, Google Cloud, and other platforms allow you to group VMs in auto-scaling clusters. New VMs are added when overall CPU or storage usage exceeds a predefined threshold across all VMs, and VMs are removed when the load decreases to save costs. Horizontal scaling comes into play when certain VMs are under high CPU or storage stress. New VMs are spun up to distribute the load more evenly. For instance, if the load balancer notices that 80% of the VMs have CPU utilization over 75%, it triggers an auto-scaling event to add new VMs to the pool. Vertical scaling, although less common in practice for load balancing, involves upgrading existing VMs with more CPU or storage to handle higher loads. However, horizontal scaling is generally preferred for better fault tolerance. Let's consider an implementation using AWS Elastic Load Balancer, or ELB, and auto-scaling. ELB with health checks. AWS LB can be configured to distribute traffic to multiple EC2 instances, which are essentially virtual machines. ELB health checks continuously monitor the CPU and storage of each EC2 instance. If an EC2 instance has low CPU availability or is running low on storage, ELB stops routing traffic to it and directs the traffic to other healthy instances. An auto-scaling group in AWS automatically adds or removes EC2 instances based on defined conditions, such as average CPU utilization greater than 75% across all instances. CloudWatch alarms trigger when certain metrics are exceeded. For instance, you can set an alarm that triggers an auto-scaling event if the CPU usage across all instances exceeds 80%. When the load decreases, EC2 instances are terminated automatically. If using a custom load balancer like HAProxy, Nginx, or a custom microservice, you can configure it to make routing decisions based on real-time CPU and storage data from monitoring systems like Prometheus or Datadog. The custom load balancer pulls metrics every few seconds and routes requests to VMs with the most available resources. Ensure there is redundancy by deploying VMs across multiple availability zones or regions. Implement automatic failover mechanisms, where if a VM becomes unavailable due to high CPU or full storage, the load balancer automatically redirects requests to the next available VM or spins up new instances. Routing requests to multiple VMs based on CPU and storage availability requires a combination of intelligent load balancing, real-time monitoring, and auto-scaling. By dynamically adjusting the flow of traffic to VMs based on their resource availability and implementing auto-scaling strategies, you can ensure that your system remains responsive, efficient, and capable of handling large loads. The choice of load balancing strategy, such as round-robin with health checks or weighted load balancing, depends on your specific requirements for performance and resource usage. Don't forget to subscribe to the channel and hit the notification bell so you never miss out on any of our informative videos. And if you enjoyed this video, make sure to like, share, and leave a comment below. We'd love to hear from you.